Okay, welcome back. This is the continuation of equation. So we'll now be talking about the word problems leading to linear equations. So firstly, what is word problem? What do we mean by this word problem leading to linear equations? This is when a statement is being made and you are meant to be translate the statement into mathematical form for calculations. So let's take a look at this example now so that if you understand what we mean by word problem leading to linear inequality, to linear equations, please. So we have examples. We have the first one, 1/3 of number added to 4/5 of itself is equal to 17. Find the number. Okay, the first thing you're going to do in this word problem leading to linear equation is first of all you understand the statement so that you will be you as in, if you understand it you can now translate it correctly, because if you not understand what the statement is all about you may not translate it correctly. And another thing is you have to use a letter to denote for the number. Like, let's go. We have 1/3. 1/3 means 1/3, 1 divided by 3 of a number. We don't know the number. So we can use any letter to represent for the number. So 1/3 of a number added to 4/5. 4/5 is 4 divided by 5 of itself, of that particular number, is equals to 17. This will be taking us back to linear equation. Okay, let's now translate the statement now into mathematical form. We have, let the number be x, because we don't know the number. So 1/3 will be 1 divided by 3 times x, because we've assumed that the number is x, because we don't know it is an unknown. We are looking for it. They say we should find the number. So 1/3 of x is added. Addition means plus. So we have plus 4/5 of itself, of that number, times x is equals to 17. So we have translated the statement into a mathematical form. We can now solve. So what are we going to do? First of all, this we have to simplify it. 1 times x will give us x. We have x divided by 3 plus 4 times x will give us 4x divided by 5 will now give us 17. So if you take a look at this, we have solved a question that is like this, the one involving fractions. So if you take a look at this, the first term is in fraction format, likewise the second term, but this last term or third term is not in fraction. What we are going to do is simply we convert this to fraction. How do we convert it to fraction? We divide by 1, because any number divided by 1 is that same number. Like 2 divided by 1, 2 divided by 1 is 2. 1000 divided by 1 is 1000. So if we divide 17 by 1, we have not changed anything. It's still 17, because 17 divided by 1 is 17. So for us to convert everything so that all of them will look alike, they will be in uniform. So we'll now be having x divided by 3 plus 4x divided by 5 is equals to 17 divided by 1. It's now left for us to go to the next step, which is finding the LCM of the denominator. We have 1, 5, and 3. And the LCM of 1, 5, and 3 should be 15. Because 3 can divide 15, 5 can divide 15, 1 can also divide 15. So we now have we have to multiply each term. This is a term. Multiply each term by the LCM. Multiply each term by the LCM, and the LCM is 15. So we're now going to have 15 times x divided by 3 plus 15 times 4x divided by 5 is equals to 17 times 15 divided by 1. So at this point, we'll be using this denominator to divide. So 15 divided by 3 will give us 5. It will now be 5 times x. 5 times x plus 15 divided by 5 will give us 3. 3 times 4x is now equals to 17 times 15. 1 divided by 15 will give us 15. 15 times 17 will give us 17. So at this point, 5 times x will give us 5x. 3 times 4x will give us plus 12x is equals to 17 times 15. 17 times 15 will give us 255. 255. So at this point, you have to collect like terms. So, but taking a look at the question, you find out that it's normal now. What we now have to do is we add up this unknown term. So we divide both sides by the quotients of x. So at this point, you have 5x plus 12x is going to give us 17x is now equals to 255. 255. So the next step is to divide both sides by the quotients of x, which is 17, to get the correct value of x. We divide by 17. We divide by 17. So x will now give us 17 divided by 255 divided by 17 is going to give us 15. That means x is 15. So that is what problem leading to linear equations is all about. It's very simple. Once you understand the statement that is being made, is if you can translate it correctly without having any issue, so you are good to go. It will be taking you to the normal equation, linear equation. So let's solve another example. Let's solve another example on what problem leading to linear equation. The second one, we have example 2. Okay, so example 2, let's take a look at this one now. A man is 4 times as old as his son. In 4 years' time, he will be 3 times as old. He will be 3 times as old. What are their ages now? So what we are going to do is we have to translate this statement into a mathematical form. So the statement goes like this: a man is 4 times as old as his son. We don't know the year, the age of the son. That means we can take any letter to denote or represent for the son's age. So we can say let the son's age be y, and the man's age will now give us a man is 4 times. That is 4 times y is 4y. So in 4 years time, you are going to add. But if they said in 4 years ago you subtract, in 4 years time we add. So in 4 years time, the son's age will be 4 plus y. So and the man's age is equals to 4y plus 4. So let's go back to the statement again. In 4 years time, this is referring to the son. He will be 3 times as old. He will be 3 times as old. So that means the son is not going to be 3 times as old as the father, because this is just trying to tell you that the age or the age of the man is equals to the age of his son. So that means in 4 years time, the father's own will be 4y plus 4 will now be equals to the age of the son. So the son will be 3 times as 3 bracket 4 plus y. So one thing we're going to do is we have to open brackets. How do we do that? We use what is outside to multiply everything that is inside. So this will now give us 4y plus 4 is equals to 3 times 4 will give us 12 plus 3 times y will give us 3y. So we've arrived at linear equation again. So it's now left for us to collect like terms and solve. Very simple. So at this point, we are going to collect like term. This one is an unknown term, 4y, an unknown term. So we have to group it in one side. Constant term, we still have to group it in one side. So we have 4y. This 3y will cross over to come and meet 4y. And it's plus here. Once it crosses, we change to minus. We have 4y minus 3y is equals to 12. This 4 is plus here. Once it crosses to meet 12, you change to minus. Minus 4. 4y minus 3y. You have 4y. And you are owing somebody 3. So you subtract. You will now give us y is equals to 12 minus 4 is going to give us 8.